This video is going to cover Trig Notes 4.1, and the topic for these notes is complex numbers. So before I can tell you what a complex number is, I want to do a little bit of an investigation. If you took out your calculator and typed in the square root of -25, you would end up with an error message. Well, we're going to talk today about how we can actually take the square root of negative numbers, which will be part of the idea of what a complex number is in just a minute. So if instead I looked at the square root of -25 as the square root of -1 times the square root of 25, you could really look at this and say, well, I can take the square root of 25, that would be 5, but I still have this negative number that I'm trying to take the square root of. So what we're going to do is we're going to introduce an imaginary unit, and we're going to call that imaginary unit I. So if I say that I is equal to the square root of -1, then really what I can say that this answer is this answer would be equal to I times 5, which would be 5I. Now technically the square root of 25 would be plus or minus 5, so this answer would be plus or minus 5I. So by introducing a imaginary unit I and saying that I is equal to the square root of -1, I can now take the square root of negative numbers. So this is going to be an important element for us to know. Likewise, if I was to actually square this, if I took I and squared it, that would be equal to, well, the square root of 1 squared is the square root of -1 squared is -1. So this is going to be another important element for us to know. So now, in the past, what we've dealt with is we've dealt with just rational and irrational numbers, and we've called those real numbers. Now I'm introducing to you this square root of -1, which is what we're going to call an imaginary number. And when we take a real number and an imaginary number and we combine them together, we end up getting what we're going to be talking about in this lesson, complex numbers. So a complex number is a real number plus or minus an imaginary number. We'll write it like this. We'll write it as the real number, then plus or minus the imaginary number. So the form that we'll typically write it in is we'll write it as A being the real number, plus then B, which is the imaginary number, and then we put an I next to it to denote that it's imaginary. This is going to be called standard form. And anytime we deal with complex numbers, we want to make sure that we're always writing it in standard form. So again, we just talked about standard form being A plus BI, where A is the real number, B is the imaginary number. And when we deal with I, we really want to think about it as just being a variable. Just like all the rules that apply with an x, when I add x's together, when I subtract x's, when I multiply x's together, they become squared, or depending on how many I have. We're going to apply those same rules to I. So I is really just a variable, but we really know that I stands for the square root of -1, or I squared stands for -1. So if I asked you to subtract complex numbers, one complex number minus another, you would use the distributive property. So you wouldn't really need the parentheses in the first set. You would end up with a -7 plus a 2i, and you would just go through and combine your like terms. 4 minus 7 is -3, 3i plus 2i makes 5i. Now again, you want to give your final answer in standard form, A plus BI, so this already is in that form, so I don't have to do anything to it. Over here, when I try to add complex numbers to real numbers, again, I won't need the parentheses at all for this problem because I'm not distributing anything in. What will happen this time is my -3 and my +3 will cancel out, and I'll just be left with 4i. And again, I want to write this in standard form, the real number plus the imaginary number, but if there is no real number, we could kind of think of it as 0 plus 4i, but we don't really write it like that. We'll just leave our answer as 4i. When we multiply imaginary numbers together, multiply the constant or the coefficients together, 4 times 5 is 20, and I times I is I squared. But remembering that I squared is the same as -1, This problem now really is 20 times negative 1, which would give me negative 20. Anytime you have an I squared, you need to change it to a negative 1, and then simplify. Multiplying an imaginary number by a complex number, we'd use the distributive property. So negative 6i minus 8i squared. Again, remember that anytime you see an I squared, it is the same as a negative 1. So this really becomes negative 6i plus 8. And again, we want to keep our answers in a plus bi form. So we would just manipulate this a little bit by moving the 8 over to the front. And we would give our answer written that way, as 8 minus 6i. When we take a complex number and we times it by a complex number, again, if we're thinking of I just as a variable, we would just FOIL this. So if it was an x, we would just go through and FOIL it. The same concept is going to happen here. So we'll multiply these two together to get 15, these two to get negative 12i, the innards to get 10i, and the last to get negative 8i squared. Now you'll notice each time that I had an I squared, I changed it to a negative 1. The shortcut, so that you don't have to write times negative 1 each time, is to look at this and say this is negative 8 times negative 1. So altogether that would give me a positive 8. So I'm just going to cross that off and write positive 8 so I don't have to go through and write it as times negative 1. So this would make 23, and these two, when I combine them, would make a negative 2i. And again, that's in standard form, so that's my final answer. When you deal with taking square roots of negative numbers and multiplying them together, you can't just multiply them together right away and say, okay, this makes the square root of 50. What you have to do first is to get rid of the negatives by making them as i's. So in other words, we said before that this is negative 1, square root of negative 1 times the square root of 5. This is the square root of negative 1 times the square root of 10. And remember, the square root of negative 1 is an I, so this becomes I square roots of 5. This becomes I square roots of 10. Now you can multiply them together. Multiply what's on the outside together. I times I would be I squared. Multiply what's underneath together. 5 times 10 is 50. Now remember, I squared is the same as negative 1. And then the square root of 50, I know, is the square root of 2 times the square root of 25, which is 5 square roots of 2. So I have to take negative 1 and times it by 5 square roots of 2. When I do this, I end up with negative 5 square roots of 2. Again, the common mistake that students will do is they'll look at this and they'll say right away, when I multiply it together, that just makes the square root of 50, which is 5 square roots of 2. And notice that my answer is not that, it's negative 5 square roots of 2. You can't just take this negative and say, well, together they make a positive. Because they're imaginary numbers, so you have to pull out the i's before you do the multiplication process. So right here. If we have a complex number that we're squaring, remember when we square a number, for example, if it was 3 squared, that's really the same as 3 times 3. Well, for this problem, this is really the same as 3 plus 2i times 3 plus 2i. You have to FOIL this. Don't make the mistake of just trying to square each of the terms. So I'm going to get, when I FOIL, 9 plus 6i plus 6i plus 4i squared. And remember, we said that a I squared is a negative 1, so this would really become negative 4. Combining like terms, that would make 5. And combining like terms in the middle, that would make 12i. That's in standard form, so that would be my final answer. Now when we deal with, again, multiplying a complex number by a complex number, but more specifically for this problem, notice the only difference is a plus and a minus here. Well, this special relationship is called a conjugate, and because these are complex numbers, we call these complex conjugates, where you just change the sign in the middle. Now when we multiply complex conjugates together, what will happen is you will end up with no more i's in your final answer. And that's going to be really important that we understand that concept when we deal with these next two problems. So let's multiply these together and you'll see how we'll get no more i's. The way we're going to multiply them together is we will FOIL. So we'd get 9 minus 6i plus 6i and minus 4i squared. Again, a negative 4i squared is going to be a positive 4, so we have 9 plus 4, which is 13, and my minus 6i and plus 6i would cancel out. Notice my final answer doesn't have any i's in it. Again, that concept is important for when we deal with these problems, where we have to get rid of the I in the denominator, because you can't have a square root in the denominator and be considered simplify. So we're going to rationalize this, and the way we rationalize is we multiply by the complex conjugate. In this case, 4 minus 2i, the complex conjugate would be 4 plus 2i. And what I do to the numerator, I must do to the denominator, and vice versa. What I did to the denominator down here, I must multiply by the numerator. So this really becomes FOIL twice. FOIL in the numerator, FOIL in the denominator. So the numerators would give me 8 plus 4i plus 12i plus 6i squared. We'll simplify in just a minute. Denominators give me 16 plus 8i minus 8i and minus 4i squared. Let's go through and change a positive 6i squared to a negative 6, a negative 4i squared to a positive 4, and when we simplify, 8 minus 6 is 2, 4i plus 12i makes 16i, and in the bottom you should get these imaginary numbers to cancel out. 16 plus 4 is 20. But again, we want to write this as a number in standard form. So this 20 is really being divided into both of these numbers. So this is really 20, or 2 over 20, plus 16i over 20. Simplifying from here, you would get 1/10 plus 4 goes into both of those, 4/5 I. Again, you want to keep your numbers in the a plus the bi form. Oops. So that would be my final answer. Simplify if you can. Remember the 20 goes into both of these numerators. Alright, so when you have a complex number in the denominator, you must multiply by the conjugate to simplify. If you just have a imaginary number in the denominator, the way that you're going to get the I to go away is by making it become an I squared. And the way we would do that is just by multiplying by another I. And what I do to the numerator, I must do to the denominator. So this would become 7i in the numerator, 2i squared in the denominator. And remember, 2i squared is the same as negative 2, so my answer would be 7i over negative 2.